Okay, question number 12, maximum mark 21 points. Consider the complex number z equal to x plus yi, where xy is real number, and such that the distance from z from 2 plus I is exactly equal to 3. Just by simply looking at this expression, this means that the curve of complex number z is the all the points which is distance from 2 plus I is exactly 3. So we can just simply imagine this means x minus 2 square plus y minus 1 square is 3 square. This is exactly the same as that one. Yeah, we can simply see that. But I'm not going to use that method. So we just simply put the x plus yi in here and just see what happens. So we got x plus yi minus 2 plus I, and the modulus of this one is 3. So we make it simple inside absolute value, put the real part together. Real part will be x minus 2 and plus I times, and imaginary part will be y minus 1, and a modulus of this one is 3. Modulus of certain a plus ib, modulus of this expression is defined by square root of a square plus b square root, right? So we can do simply put square root of x minus 2 square plus y minus 1 square. This is 3. So we take square on both sides, square, and the left hand side becomes x minus 2 square plus y minus 1 square is 3 square is 9. And expanding the expression, we got x square minus 4x plus 4 plus y square minus 2x plus 1 equal 9. And then we just simplify this expression one more time. We got x square plus y square minus 4x. Oh, this, how come this one become x? This is 2, actually 2y over here, right? So minus 4x minus 2y, and then we got 5, negative 9, and becomes negative 4 equals 0. So this is exactly the expression the question wants us to get, which is that one, same. Okay, so the second question, it says the argument of this expression is pi over 4, where pi is real number. Show that this one makes sense. The argument of a complex number over a complex number is decided by the Moivre theorem, that the argument of the top part minus argument of a lower part. Okay, so that is by the Moivre theorem. So argument of that one, this one we can think argument of top part is, as you see, top part is x plus p plus yi, and over z minus 1 is x minus 1 plus yi. So argument of top part, we can say arc tangent y over x plus p. And then argument of denominator minus is minus. Argument denominator is arc tangent y over x minus 1. And then on the question, it says this argument is pi over 4. When there's the two arc tangent like this, and we just take we can just take tangent on both sides, yeah, and then use a double compound angle identity of the tangent. So we take tangent on both sides. So left hand side will be tangent A minus tangent B equal tangent A minus tangent B over 1 minus tangent A tangent B. It goes like that. So when tangent and arctangent come together, it cancels each other out. So we can say y over x plus p tangent b minus tangent b is tangent arctangent cancel out, y minus x minus 1 all over 1 minus tangent a, which is y over x plus p tangent b y over x minus 1 equal tangent pi over 4 is 1. So we can say y x plus p minus y over x minus 1 equal 1 minus is y squared x plus p x minus 1, like that. Next we can multiply x plus p x minus 1 on both sides. See what happens. Left hand side will be x plus p is cancels out. It's going to be y times x minus 1 minus y times, this time x minus 1 cancels out, so x plus p equals x plus p x minus 1 and y squared remaining. And simplifying this equation, we got xy minus y minus xy minus p times of y equal, expanding these, we got x squared plus p minus 1 times of x minus p minus y squared. Okay, and this and that cancels out. And then simplifying based on the right hand side, we got the x squared minus y squared plus p minus 1 times of x, and then these two is minus p plus 1 going to the other direction. It comes with plus p plus 1 times y, and then minus p equals 0. So let's see if this is what they want. Yeah, x squared, yes, I applied the wrong. So this tangent a minus b equal tangent a tangent minus tangent b, and this is plus over here, so I made a mistake. Plus over here, and then it will be plus over here, and it will be plus here, so that it's going to be plus over here. So this is exactly same as x squared plus y squared plus p minus 1 of x plus p plus 1 of x minus p equals 0. Okay, we got it. Next question. The root of the equation of this quality equation are z1, z2, where z is a complex number, a, b, c, d is a real number. Both z1, z2 satisfies. First condition is the distance from 2 plus I is 3 is exactly the same condition of this one. And second condition is argument of this one is pi over 4. If you see carefully, inside the parentheses, the top part, which is a numerator, z plus 4, which originally it was z plus p. So that means, this means p equal 4, right? P equal 4. So use the result from part A and B, find z1, z2. So z1, z2 when p equal 4. So result from part A and part B, first result is this one. First result is this one, and second result is that one when p is 4. So we can write it down. First result x squared plus y squared minus 4x minus 2y minus 4 equals 0. And second equation, when p equals 4, we got x squared plus y squared. When p is 4, it's going to be plus 3x plus 4 plus 1 is 5y minus 4 equals 0. So find the z1, z2. All we have to do is find x and y for this expression. So let's find x and y using this format. Just by simply subtract a second equation from first equation, we got minus 7x minus 7y equal 0. So we can say 7x equals, okay, minus 7y equals 7x. So simply x is negative y, right? So x equals negative y, we can just simply put into first equation. We got x squared, y is negative x, so it's negative x squared is plus x squared, minus 4x, y is negative x, so plus 2x, minus 4 equals 0. We got the 2x squared minus 2x minus 4 equals 0. So divide by 2 both sides, we got x squared minus x minus 2 equals 0. So 2, 1 negative, so x minus 2, x plus 1 equals 0, which means that x can be 2 or x can be negative 1. When x equals 2, because y is negative x, is y equals negative 2. When x equals negative 1, y is negative x, is y can be 1, which means that z1 can be 2 minus 2i, and z2 can be minus 1 plus I. So this is z1 and z2. This is z1 and this is z2. Okay. Find the value of a. So find the value of a. We got the z1, z2. So z1 is, let's see, the first root is 2 minus 2i. So first root of this equation is 2 minus 2i, and the second root of that equation is minus 1 plus I. Minus 1 plus I. I'm going to get rid of p equal 4, this format over here. Okay, there must be 4 root, okay? We already know two root of this equation. So, because the complex root always exists as a conjugate, we can say that, excuse me, if 2 minus 2i is a root, we can also say 2 plus 2i is also root. If this one is also, we can also say minus 1 minus I is also the root of this equation over here. Because complex roots are always exist as a conjugate. And then we need to find the value of a. So as you see, value of a is coming from sum of all roots is minus the coefficient of the highest degree value is 1, is the second highest coefficient of second highest degree is a. This is the sum of all roots. Is adding these 4 together. We got adding the first 2 number, we got 4 minus adding second 2, we got minus 2, right? So it's 2. So which means that a over here it says from here we can say minus a equal 2. So a is 2. A is negative 2 actually. A is negative 2.